Hello, I'm Andrew Hoffmeyer.
And I'm Austin Greer. We're going to be talking about electromagnetic and ultrasonic flow meters.
Ultrasonic transit time flow meters measure the difference between transit time and ultrasonic pulses, propagating with and against the flow direction.
The major components of a transit time flow meter are the downstream transducer, the upstream transducer, and the ultrasonic flow path. The downstream transducer sends out an ultrasonic signal to reflect off the opposite side of the wall. The upstream does the same, and the two are compared to decide a rate of flow.
A Doppler ultrasonic flow meter measures the frequency shift between the ultrasonic frequency source, the receiver, and the fluid carrier. The relative motions are measured.
The key components to a Doppler ultrasonic flow meter are the transmitter, the receiver, and the reflectors. The transmitted ultrasonic signal will be reflected and then received to determine the velocity of the flow.
Our third flow meter is the electromagnetic flow meter. It uses Faraday's law of electromagnetism to measure flow rates. It creates a magnetic field by running electrocurrent through a coil that surrounds the flow tube.
The main components to an electromagnetic flow meter are the exciting coil, the electromagnetic flow meter detector, and the electrode. A magnetic field is created with the coil that creates a voltage in the liquid, which is detected by the electrode. Here, the force diagram is depicted by hand.
Advantages to using an ultrasonic transit time flow meter are that it is low cost installation, no need to shut off your system and stop working, and it will not contaminate or disturb your material. Disadvantages being that it is inconsistent in accuracy below 2 feet per second. The airspace in the pipe will also affect this accuracy. The more airspace in the pipe, the less accurate your reading could be. Reasons to use a Doppler ultrasonic flow meter are that it is non-invasive and you do not need to contact the liquid. This is also insensitive to liquid temperature, viscosity, and pressure changes. Disadvantages are that the liquid must contain these particles, bubbles, or solids for it to work. Finally, advantages to using an electromagnetic flow meter are that there is no pressure drop and it responds well to changes in flow. This is useful for liquids with large particles. Disadvantages are that it is limited to the amount of microsiemens in the water. Microsiemens is the amount of electroconductivity the water contains. Airspace in the pipe will also affect this reading.
So, in a Doppler ultrasonic flow meter, a transducer emits an ultrasonic beam into the liquid flowing in the pipe. The frequency is reflected off of the particles in the liquid to the receiving transducer. The frequency shift is linearly proportional to the flow rate. If there are no particles in the liquid, a transit time ultrasonic flow meter is used. It compares the measurements of upstream and downstream measurements. Frequencies bounce off of A and back to B. When flow is present, the sound moves faster when traveling in the same direction as flow, and slower if moving against. If there is no flow, travel time is equal. Solids and bubbles will cause frequency to be weak. So in conclusion, the difference between Doppler ultrasonic flow meters and transit flow meters is that Dopplers reflect frequencies off of liquid and transits traverse from both sides of the pipe.
Now we're going to explain how electromagnetic flow meters work. An electromagnetic flow meter measures the velocity of a conductive liquid moving through a pipe. This type of flow meter has no moving parts, making it very low maintenance and ideal for wastewater systems. A magnetic field is created from the coils on the top and the bottom of the flow meter across the pipe. Two electrodes are placed at a right angle on the wall of the pipe. These are there to detect electrical voltages in the fluid. As the conductive liquid flows through the pipe, the magnetic field causes a force on the conductive particles. This then creates an electrical voltage which can be detected by the two electrodes. The voltage is directly proportional to the flow. A higher voltage will represent a higher velocity. There are a few things you should know before you select an electromagnetic flow meter. Is the fluid conductive or a water-based fluid? Is the fluid type slurry or abrasive? The size of the pipe, the typical fluid level of your pipe, and the maximum flow rate of the meter. The principle of the electromagnetic flow meter is based off Faraday's law of electromagnetic induction. When an electrically conductive liquid flows through the pipe, the induced voltage, E, is picked up by two electrodes on the side of the pipe. E being the induced voltage is equal to K, the instrument constant, multiplied by B, the magnetic flux density, multiplied by V, the average fluid velocity, multiplied by the diameter. The induced voltage, which is E, is directly proportional to the average fluid velocity. As any of these values increase, so will the induced voltage. The Doppler ultrasonic flow meter operates on the basic principle of the Doppler effect. The Doppler effect is the effect of a sound wave changing frequency. In the case of ultrasonic flow meters, the frequency of an ultrasonic signal changes in proportion to the rate of the flow of the liquid when reflected by the suspended particles. The transducer generates an ultrasonic signal that passes through the pipe wall into the flowing liquid. The transmitter then converts the difference between its output and input frequencies into electronic pulses. These pulses are then processed and scaled into a measurement of flow.
There are several things to consider before selecting a Doppler flow meter. Does the liquid have particulates of 100 parts per minute of 100 microns in size? The size of the pipe, typical fluid level of pipe, minimum and maximum flow rate of meter. Will it require a handheld monitor? You should also be aware that different flow meters have different applications. Ultrasonic transit time flow meters should be used in the following conditions: low aeration systems, fluid with few particles, and clean and pure systems. Doppler ultrasonic flow meters should be used in systems with large particles and bubbles, when flow cannot be shut off, and in dirty and corrosive fluids. Finally, an electromagnetic flow meter should be used in water-based conductive liquid, drinking water, wastewater treatment, large line sizes.
Here are some key things to take away from our presentation. More airspace in the pipe can affect the accuracy. The more airspace in the pipe, the less accurate the reading could be. To use an electromagnetic flow meter, the liquid needs to be electrically conductive. Doppler time flow meters need particles and air bubbles to work. Electromagnetic flow meters are useful for wastewater systems, large line sizes, and any water-based liquid. The voltage is directly proportional to the velocity of flow. Ultrasonic flow meters are useful for fluids that cannot be contaminated or disturbed. There's no need to actually come in contact with the liquid. Transit time flow meters compare upstream and downstream times. In the handout provided, we summarized our presentation into a table. The table includes the type of meter, the basic components, applications, advantages and disadvantages of all the flow meters. The handout also includes the basic principles behind every type of flow meter. We also include Faraday's law of electromagnetic induction and list the variables and their meaning. Faraday's law is the governing principle behind electromagnetic flow meters.